Hello everyone, this is Chaitanya from Sri Venkateshwara College of Engineering presenting you the technology which is trending in the market, that is autonomous cars. The contents that we'll be going through in the further slides are introduction, history, technologies used, key components, levels of autonomous cars, Tesla being the example for autonomous cars, working, benefits, challenges, and finally the conclusion. And here the question is, what are autonomous cars? An autonomous car is a vehicle that is capable of sensing its environment and operating without human involvement. A human passenger is not required to take control of vehicle at any point of time, nor is a human passenger required to be present in the vehicle all the time. An autonomous car can go anywhere like a traditional car goes and do everything that an human experienced driver does. Moving on to the history, the idea of self-driving cars has been around for many decades, with early versions dating back to the 1920s. However, the technology was not advanced enough to make autonomous cars a reality until recent years. Here is a brief history of the development of autonomous cars. During 1950s, the first autonomous cars were developed for research purposes. One of the earliest was a modified Cadillac that used magnetic wires embedded in the road to guide the vehicle. Nextly, during 1980s, the first semi-autonomous cars was developed. Carnegie Mellon University created the NavLab, a vehicle that used cameras, sensors, and a computer to navigate a predefined route. In 1990s, Mercedes-Benz developed the Autobahn pilot system which allowed cars to drive themselves. In 2010s, Google announced that it had developed a self-driving car that had driven over 140,000 miles without human intervention. And this was a major milestone for the development of autonomous cars. Other car manufacturers such as Tesla also began developing their own autonomous cars. And during 2020s, autonomous cars are becoming more advanced and more common on roads. Many companies are developing autonomous ride-sharing services. Governments are also working on regulations to ensure the safety and reliability of autonomous cars. Overall, the history of autonomous cars have been a long and challenging road, but recent advancements in technology are bringing us closer to the future where self-driving cars are a common sight on the roads. Two major technologies that are used in autonomous cars are artificial intelligence and blockchain. AI can be used for training autonomous cars to make decisions in various driving scenarios. The AI algorithms can learn from real-time data collected from sensors, cameras, and other sources. This data can be used to train the AI models to make better decisions in different scenarios. In this case, the vehicle has to decide whether to stop or keep moving whenever it detects the obstacle or object. On the other hand, blockchain technology can be used to securely store and share the data collected from autonomous cars. Blockchain can provide a decentralized and immutable ledger that can enable secure data sharing between different parties. What is blockchain technology? Blockchain technology is a distributed digital ledger that is used to record transactions across many computers. The shared digital ledger keeps a record of all the transactions happening between the nodes of a blockchain network. These ledgers can be a powerful tool for data sharing. The log of each transaction gets recorded and each node possesses an identical copy of this ledger. Any change made by any of the nodes instantly gets reflected on the ledgers of all the nodes in the blockchain network. This is how the actual blockchain network works. Firstly, we need to create a blockchain of number of autonomous cars, and then we need to train any one of these cars using reinforcement learning or any other artificial intelligence algorithms. For instance, assume that we have to train the car to stop at red light. Then we'll be training only one car stating stop if red light is equal to S, else you'll run into traffic, meaning that the car should stop if at all there is a red light, or else the car will run into traffic. This trained car then updates this knowledge in its ledger, which is automatically shared to all the other cars' ledger in the network. Thus, training all the cars in the network with only one training procedure is done. Here is the example. Let us consider the blockchain network of cars. Here, car number 1 is trained by the input accident on highway at this particular date, month and year. So it is representing the caution. So car number 1, as it is trained, it acts as sender. All the other cars which are in the blockchain network acts as receiver. This trained car, which is car number 1, sends this particular input or the trained input to all the other cars in the network using the blockchain technology. Let's go through the key components. First step is to detect the object, including vehicles, pedestrians and obstacles, which is termed as object detection. Then the car's position and orientation is determined by the sensors, which is termed as localization. After positioning the car, the sensors are used to create a map of the environment, which is used to plan the car's route and avoid obstacles, which is termed as mapping. After mapping the environment, the data from the multiple sensors are combined together to create a comprehensive view of the environment, which is termed as sensor fusion. After combining the data is processed. The car's onboard computer processes the data from sensors in real time using advanced algorithms to create a 3D model. How automated vehicles work. The four different components that are used in automated vehicles are LiDAR, radar, cameras, and GPS. LiDAR stands for light detection and ranging. These sensors use lasers to measure distances to objects and create 3D maps of the surroundings. LiDAR is one of the most important sensors used in autonomous cars as it provides a high level of accuracy and precision. Radar sensors use radio waves to detect objects and measure their distance, speed, and direction. They are especially useful in poor visibility conditions such as rain or fog. Cameras are used to capture visual data and can provide important information such as object detection, lane markings, and traffic signals. GPS stands for Global Positioning System, which is used to determine the location of the vehicle and can be used in conjunction with other sensors for navigation and mapping. This picture represents the conversion of stereo image into 3D box using LiDAR sensor. Firstly, let us consider any of the stereo image. Then, we'll be estimating the depth of the image. Using the estimated depth map is being generated. Then, using the LiDAR sensor, based on the depth map, 3D objects are detected from the depth map. Using 3D objects that has been detected, the 3D boxes are predicted. So finally, we'll be having the prediction of 3D boxes at the end. Self-driving vehicles are able to pick up passengers on demand and take them to the desired destination. Autonomous vehicles are also able to recognize traffic lights, road signs, intersections, and act accordingly. But how do they actually do all this? As we all know, self-driving cars do not require any driver to move from one place to another. The technology includes many sensors such as LiDAR sensors, ultrasonic sensors, cameras, and radar sensors. The sensors are located at the front and rear of the vehicle. Cameras and LiDAR sensors are frequently found on the roof. Without them, the vehicle would be virtually blind. LiDAR is a key component in many vehicles. LiDAR works similar to radar. However, LiDAR does not recognize road signs. Cameras use artificial intelligence to recognize and interpret street signs. Cameras are also used to detect obstacles and they are used for lane keeping. Neither LiDAR nor cameras can handle far. In this situation, radar is needed for collision warning and avoidance. A major disadvantage of radar is that the objects must be large enough to be detected. Pedestrians or cyclists cannot be recognized by radar. The exact position of the vehicle is determined by GPS in highly accurate digital maps. Digital maps contain a lot of information, including information such as intersection signs and speed limits. Here is an autonomous car where the function of long range radar is to control the adaptive cruise, emergency braking, pedestrian detection, collision avoidance, and so on. The function of LiDAR is environment mapping, and blind spot detection. The function of camera is recognizing the traffic sign, lane departure warning, which also acts as mirrors. And the function of short or medium range radar is cross traffic alert, rear collision warning, and so on. There are 6 different automation levels of autonomous cars, ranging from level 0 to level 5. If at all the car do not have any autonomous features, then they are grouped under level 0. If the cars can handle only one task at a time, for example automatic braking, then they are grouped under level 1. If the cars would have at least 2 automated functions, then they are grouped under level 2. If the cars can handle dynamic driving tasks but might still need intervention, then they are grouped under level 3. If the cars are officially driverless in certain environments, then they are grouped under level 4. If the cars can operate entirely on their own without any driver presence, then they are grouped under level 5. One of the examples for autonomous car is Tesla. Tesla's basic autopilot system is standard on all the cars it sells in the UK. This combines adaptive cruise control, emergency braking, blind spot monitoring, and lane keeping assist systems. Essentially, once you are on the motorway, it will match the speed of the car in front and keep you in your lane with little input from the driver. The Tesla Model 3 can be equipped with enhanced autopilot which can change lanes, where you just need to indicate and it will monitor the surroundings and move over if it's safe to do so. Then there's the full self-driving capability, an expensive option which gives the Model 3 the ability to stop at traffic lights or stop signs. Tesla says it will soon be adding the ability to auto steer on city streets. Here is Mercedes-Benz Drive Pilot, which was arrived on roads in Germany in 2022. It is only authorized to operate at speeds up to 40 meters per hour. It becomes first level 3 autonomous driving system to be certified for US roads. Next, it's BMW 7 Series. It has been redesigned for 2023 and the latest generation brings with it a hands-free driving system for highways. The self-driving system is designed to work on select highways in US and Canada and functions at the speed of up to 85 meters per hour. Here are some of the benefits of autonomous cars. Firstly, it's increased safety. Autonomous cars have the potential to greatly reduce accidents caused by human errors such as distracted driving or drunk driving. Nextly, it's reduced traffic congestion. With autonomous cars communicating with each other and coordinating their movements, traffic flow could be optimized and traffic congestion could be reduced. Next, it's lower emissions and improved fuel efficiency. Autonomous cars can optimize their speed, acceleration, and braking to reduce fuel consumption and emissions. Next, it's greater mobility for elderly and disabled people. Autonomous cars could greatly improve mobility for people who are unable to drive themselves, such as the elderly or disabled people. Here are the challenges that has to be addressed. Firstly, it's safety. While autonomous cars have the potential to greatly improve safety on the roads, there have been several high-profile accidents involving self-driving cars that has to be addressed. Public perception. Many people are concerned about the safety and reliability of self-driving cars, and there's a lack of trust in the technology. Cost. Autonomous cars are currently more expensive than traditional cars, which could limit their adoption. Finally, it's infrastructure. Autonomous cars require advanced infrastructure such as high-speed internet and communication networks to function properly. So these kind of challenges has to be addressed properly. And here is the graph based on the survey which represents the annual increase in number of vehicles equipped with hardware for fully autonomous driving. We can see the graph from 2018 to 2023 where the number has gradually increased from 1,37,129 to 7,45,705. This growth has to be appreciated. This graph represents the percentage of consumers who think self-driving vehicles are not safe. And the comparison is made among different countries in the year 2020. And this tells us that when compared to other countries, India is the country which has more number of consumers who think that the self-driving cars or the self-driving vehicles are not safe to use. Finally, to conclude this, however, there are still challenges that has to be addressed before autonomous cars can become a widespread reality. One of the main challenges is ensuring the safety and reliability of the technology, as well as addressing ethical concerns around decision making in potentially dangerous situations. Additionally, there are concerns around the impact of autonomous cars on employment, as they may lead to job losses for human drivers. Overall, while there are still challenges that has to be addressed, the potential benefits of autonomous cars are significant and they are likely to play an increasingly important role in transportation in the coming years. And that's the end of my presentation. Thank you so much.